We covered the first question from the 2014 paper, and there was some issues that I've noticed, so I'm just going to go over these. So we consider the two-stage adiabatic compression process with isobaric. Remember isobaric intercooling. After the first stage, that brings the gas back to the temperature, and both stages have a pressure ratio of 5. The issue was with part F and G. Part F and G. To start with, we'll go over part F. Calculate the molar fluid work after the final stage of the process. So this is after effectively after it leaves the compressor. So it's not adiabatic, but rather it's just fluid work in a system. So if we try to calculate that, so 2014 focus, question 1, part F. Calculate the fluid work after the final stage. Now we know that fluid work equals negative PV, and this is because we're considering fluid work after the compressing stage, so only within the system. And we know that PV equals nRT, hence fluid work equals negative nRT. Therefore, fluid work in this case equals negative 8.314 multiplied by 475, the temperature, and it's for 1 mole. So the fluid work is 3,950 kilojoules. Now to continue, I'm just going to go over part G. Now when there was a mistake in part G, if I show you the question again, calculate the total shaft power in kilowatts at a molar flow rate of 5 moles. Now there are 2 stages. So to calculate this, there are 2 adiabatic stages. Hence we use the formula W. So this is part G rather. We can use the formula shaft work equals 2WS 1 to 4. Therefore the equation becomes 2 times gamma nRT 1 over gamma minus 1 multiplied by 1 minus P2 over P1. Remember 2 is the number of stages, so n equals 2 in this case. This is shaft work. Therefore gamma minus 1 over n gamma, which was missing. And to calculate gamma minus 1 over n gamma, which is the number of stages, equals 7 over 5 minus 5 over 5 all over 2 times 7 over 5. Therefore it is 2 over 5 over 14 over 5, which equals 2 over 14, and hence 1 equals 1 over 7. Now if we plug these in, 2 times 7 over 2 this is your gamma over gamma minus 1 times 5, that's the number of moles, times 8.314 universal gas constant times the initial temperature, multiplied by 1 minus the pressure ratio, which is 5 to the power 1 over 7, which all equals to negative 22,566.2 watts, or negative 22.6 kilowatts.